Welcome to video 3 of the Sampling Concepts, Procedures, and Plan Application for Water and Wastewater Operators. We're going to go on to the documentation portion of the presentation, and then we've got a few other things to touch base on. One is definitely on the safety side, but the documentation is very important, especially if you are a lab that has a certification that requires that your documentation be top-notch. So your sampling labels, when you get your bottles and you're ready to have those sampled, you should know exactly what they are. So you need the sampling labels. We'll go over your sampling analysis sheets, chain of custody, which is very important, and then also the operator logbooks. So that's all that'll be included in this documentation portion. The lab samples should be complete with your sample parameters. You have to have your sample time, that is when you took the sample, the location of the sample. It's influent, effluent, may not be as detailed. You may have to say this is the influent 1 sample of the air bay, or this is the raw sample taken from the headworks, and you give whatever location. So sample location A, sample location 1002, whatever you decide that you're going to have your sample location. And in some cases your permit tells you exactly where that sample location is. So you look at your NPDES permit and you find that location and you label it so everyone knows this sample point is the same point that is in the permit. So you have your sampling labels with your parameter, your time, your location, and who's doing the sample. Either you do a signature system or you do an initial system. But if you have someone named Mike Smith, and then you may have a Miguel Sanchez, and they're doing a MS system, you don't know if it's Mike or Miguel that is doing the sample. So you might have to do first name, last name, or first initial, last name, or if you're doing the initial system, then you maybe have to do it where when you do have people with 2 initials, that you distinguish them somehow. The sampling information should be filled out on the label before the label is attached, and the reason why is if you're going to write on the sample bottle and it's curved, then you're not going to want to have a curved surface, in some cases a wet surface, that you're going to be writing on. So you want to make sure your sample labels are done first, and then peel them off and stick them onto your sample bottle or your vial. And that's going to make sure that all that information doesn't get lost because it's going to get washed off or whatever. And you do it in enough time, so if you're having any kind of ink, and ink gets to dry, or if there's a marker that you're using, the marker has time to dry. So that's basic information. You're going to want a unique identification number to all your samples being into the lab sampling. So let's say you have 3 raw samples, and you don't want to have your logbook say just headworks raw sample. You may want to say raw sample A, B, C, or give it a series of numbers where it can indicate your time, where it could be raw sample 0700, 0710, 0720, or something like that, where it's a unique identifier. So when you need to track that sample, you don't get it mixed up with something else. Your analysis sheet, you should have all the sampling data. It's good to have your math equations so you don't have to look around to figure out, okay, if it's a total suspended solids test and you need to write down the dry weight and then the tare weight and then do that equation to get your actual concentration. It's good to have that all there on your analysis sheet. Electronic analysis spreadsheets, such as programs like HawkWims. That's one that I'm very familiar with. You can start with your written documentation, which you would have to start with something in paper, and then later on you move that forward and you put it onto your spreadsheet in your HawkWims program. Calibration data, very important to have whatever the calibration data is, when it was calibrated, what you used, what 2 points, or sometimes there's a 3 point calibration. Just add that all in, and that's part of your documentation. The operator that's taken a sample should give a signature or initials, and the identification numbers for the sheet. Everything should be there, just easy and readily accessible. Chain of custody sheets. This is the life of the sample from the moment it was taken to the moment it leaves each individual person and handler's possession until the sample results are in. And once the results are in, then that's where you're writing all that information in. So the life of that sample should be in what's called that chain of custody sheet. All the samples, especially if you're going through a certified laboratory, one of the first things they'll ask to see is your chain of custody sheet, because they want to make sure the documentation is right. And your chain of custody sheet has the same information as your sample labels. You can add additional information to the chain of custody sheet, but at least have the information that's on the sampling labels. Florida law and most laws is where you have to retain that information for 5 years after the sample is taken. Your signatures or initials in the chain of custody sheets indicates that you, whoever's taking that sample, you are responsible for the life of that sample up to the point you sign it off to someone else. And you're saying that it's been in your possession, or it's you've seen where it's gone, and at no point did that sample either it wasn't in the refrigerator, or from whatever time period, or from your sample point to where you put it in the refrigerator, it's been in your possession. Your operator logbook, not the one that's in the lab, but the operator logbook in the control room or wherever the operators write in their day-to-day activity. That's a good place to also include your samples. Most permits, NPDES permits, have that written in, that operators have to write down what they're doing on their day, if they're doing a maintenance activity, a process control function, or a laboratory sample. And you write that into the logbook of 3 a.m. took total suspended solids from the air bay, and this is the operator who did it, and that's how the operator logbook should look like. So rule of thumb here: when in doubt about a sample or situation that may affect the sample's accuracy, write it down on the operator's logbook and sample in the sample analysis book. So if you don't know, something looks a little bit different, and you got to figure out, hey, I don't know if this means anything or not. Should I write it down or not? Just a nice little rule of thumb is go ahead, write down whatever condition you see, and make sure it's documented on paper so someone could follow along. All right, that's quick with the documentation portion, and we're going to go into the laboratory safety. This is going to be a little different than what some of you guys are used to, because in the laboratory and chemical handling portion, we're going to go over the new globally harmonized system for classification and labeling of chemicals, and that, very short, is GHS, the new globally harmonized system. This is something that America has adopted through the UN. Many of our our entities, our regulatory bodies like OSHA, Occupational Safety and Health Administration, DOT, Department of Transportation, even the Department of Agriculture, they have all adapted this new global system. So what that means is, globally, all your chemicals are not only going to be labeled the same way, but that information that comes out to you will be uniformed, and we'll go over that as well. So you'll see a lot on that. The types of hazards in a wastewater laboratory, there's several of them. The standard meth that also has a part 1090, and in that 1090 part tells you about hazards in the lab. There's infectious material, corrosive material. You have toxic, explosive, and inflammable material. So that's all there in the lab. One of the first things we'll go over is your bloodborne pathogen program, and this is a slide presentation that was open source from OSHA, the Occupational Safety and Health, and I'm going to present this one for you. So what are your bloodborne pathogens? They're microorganisms present in the human blood that can cause disease. There'll be a virus, a bacteria, parasite, fungi, anything that is carried in the blood that can give you some sort of disease or illness. So primary workplace pathogens is the human HIV, the hepatitis B, and the hepatitis C. Those are the hepatitis B and C are the ones that you may see more in wastewater because you're handling raw sewage. But the AIDS and HIV is not common in wastewater, and there is no known cases of HIV infection through wastewater exposure or in the water treatment exposure. So that's a big one to remember. But early symptoms of the HIV and which leads to the disease of AIDS, and that's the acquired immune deficiency syndrome. I don't know if I had that in the previous slide or not, but that's what that means. And your AIDS is coming from your bodily fluids, such as blood, if that gets into or semen, vaginal secretion. Those are ways that you could get the HIV gene that can lead to AIDS. So your early symptoms resembles a common cold, your flu virus. Your antibody test will show you if you have HIV present. So this is not contact from water or wastewater. It'll be contact from your fellow employee. And so if no matter how much you know somebody and they're bleeding and you see that blood, you should protect yourself with some sort of barrier so you don't get that on yourself or in your body, and that's actually where you're getting the passage of a disease such like that. On the other side, the hepatitis, as you see on this, the HBV, your hepatitis B virus, millions of people, they are affected by this. And some of the symptoms are the jaundice, fatigue, abdominal pain, no appetite, some nausea and vomiting. And you do have a vaccine available for the hepatitis B, and it's a series, so make sure you take the series of the vaccine and not just the one shot. Your hepatitis C, which is the most common chronic bloodborne infection. 3.9 million people are affected at the time of this presentation with OSHA, so I'm not too sure when this one was put together. The symptoms can take years to manifest. Flu-like symptoms, the jaundice again, dark urine, fatigue. Get a loss of appetite and some nausea, vomiting, same abdominal pain that you're getting. Treatment is marginally effective, meaning it's still going to be with you, but your treatment is going to relieve some symptoms as opposed to getting the HCV out of your system. How is those pathogens transfer your modes of entry? And here is it: contaminated, sharp needles, sharp objects or needles, broken skin, including rashes, your meniscus membranes, eyes, mouth, nose. Those are the type of membranes that carry it's a mode of entry into your body. And how you get exposed: contact with a coworker who suffers from a bleeding injury, That's how you're going to get your exposure for the HIV, as opposed to someone thinking that they're working in wastewater or in the water industry, and they're going to get it through the raw water source or through raw wastewater, and that's not how that virus works. It's too short-lived, so it can't live outside of a host very long. Contact with the blood while administering first aid, that's a way of an exposure. Touching a contaminated surface, that's why it's very important to clean up the lab and keep it cleaned. Any assigned to clean blood, if you are assigned to clean up blood, you make sure you protect yourself. Contact with the contaminated paper products or equipment in the restroom. Use of equipment covered with dry blood. So that's some exposure. If it's dried blood, you're not getting exposure to HIV because, again, it's a very short-lived organism outside of a host, but you could get the Hep B and Hep C from that. OSHA has some bloodborne pathogen laws. Whenever you see 1910, you see 29, which is the Department of Labor. Anything under labor in the U.S. is under Title 29 in the Code of Federal Regulations, that's CFR. So under Title 29 in CFR, 1910 is the general industry standards, 1926 is the construction standards, but in 1030, there's a requirement for bloodborne pathogens, and that's to protect the employees. So that requirement tells you that you have to have a written exposure control plan, ECP, if your employees are reasonably exposed to blood. Engineering and work practice methods controls are your number one controls. Engineering is number one. Engineering means if there's a way that you could dispose of the needles through some sort of container or something that you could remove the hazard because now it's contained some other way. That's an engineering control. Work practice control is also called an administrative control. And the administrative controls is a work rule. You're just telling someone, here's my rule. Our rule is if you deal with needles, you're going to put them into our special needle handling kit or bucket or whatever it is. And in wastewater and water treatment, you deal with ampules a lot. And the ampules are what you're using to get your reagent in mix with your sample. So once those ampules are done and you're finished with your lab test, you would have had to have broken off the tip of the ampule in order for the vacuum system to work to suck up the sample into the ampule for contact with the reagent. And now you have a very sharp tip. So you need to dispose of that correctly. So your work rule could say after you finish sampling, all ampules must be disposed of in the approved container, and you provide that container for the operators. And then the last form of protecting yourself is the PPE, and that is your personal protective equipment. So PPE is gloves that are puncture resistant, or latex gloves if it's you're dealing with water and wastewater. You protect yourself from the water that way, or if you're cleaning out a pump, you may not want to use just latex gloves for sticking your hand into an impeller or a volute of a pump to pull out some rags. You're going to want to use very strong gloves that are made puncture resistant, and they're going to be where you could grab a hold of the items in the pump and pull them out without getting yourself exposed to a needle stick. In the law, you also have a training criteria, a medical surveillance criteria where you have to do some sort of follow-up medical surveillance to make sure that there's no degradation of health due to your work. Signs and labelings of any material that can be a hazard, bloodborne pathogen hazard, or create one. And then you have your other equipment and procedures. You have to follow those things. And that's the breakdown of the 1910-1030 bloodborne pathogen laws. Universal precautions. This next slide is telling you about universal precautions. And what that is in a nutshell is this. If you see any bodily fluids from anyone, regardless of how close you feel you are to them, you are going to treat it as if that blood or bodily fluid is infected with something. So that is your universal precaution. In your mind, you're thinking, this blood is tainted. This bodily fluid is tainted. And I have to protect myself by use of gloves, masks, aprons, eyewear, protective footwear, whatever you need to have a barrier between you and that blood or you and that bodily fluid. That's what you're going to use. And then immediately you clean it up and decontaminate the surface area. And a 1 to 10 ratio of meaning 1 for every milliliter of bleach, you use 10 milliliters of water, and that's your 1 to 10 ratio, and that's good enough to sterilize or to disinfect, I should say, any of the area that you're working with, the surface that you're working with. Here's a list of some of the PPEs. Then that's of course personal protective equipment. And once you're using these PPE for your job, you should have some training. And if any of that involves a dust mask, once there's 2 straps going onto that dust mask, it leaves the filtering face piece portion where now the filtering face piece is a disposable respirator. The difference is, once you talk about a respirator as opposed to a filtering face piece, the little 1-strap face piece that you could get from the Home Depot shelf or any of those other box stores, is once it has 2 straps on it, the majority of the protection that's coming from the mask is a filter and a respirator. And if it's a respirator, you fall under a respirator program. And that respirator program first requires medical surveillance. You have to do some sort of medical testing to show that you can wear a respirator. Second is a fit test. It has to be either a qualitative test or a quantitative test, one of the two. Either you're going to go on a machine and it's going to supply air and someone's testing your blood pressure, testing you to make sure that you can keep up with that without having any heart arrest or discomfort in any way. Then the other test is where someone's going to put a respirator on you. You do a positive displacement test where you put your hands on the filter piece, blow out, and once you blow out, the mask that you're wearing should kind of puff up, and that's one of the positive tests. And then the negative displacement test is you still put your hand over either it's a front canister or the side canisters, wherever the respirator piece is, and you suck in. And once you suck in, then the mask should be sucking into your face as well. And if that happens, you have a good seal. But if the mask does not either blow out with the positive or suck in with the negative test, then your seal of your mask isn't good, and there's air getting in. So if there's air getting in, your protection isn't good. So that means you have to either shave, well, you can't have any kind of beard around the fitting of a mask. So you would have to do something to make that fit better. Get a bigger mask, a smaller mask. And this is an annual training and an annual test and an annual medical review, because people body type changes from year to year, and the equipment, you may have to get more up-to-date equipment, so now people have to be trained on new equipment, so it's an annual requirement, and that's also found in the 1910 rule of OSHA. Puncture wounds. If you got some punctures, it's coming from direct contact with something sharp, so get yourself a barrier against that by using tools. Use tongs or forceps or whatever tool you can to pick up the sharp objects. That way you're protecting your hands, and now you're not going to get that through your gloves. So here's some do's. PPE, disinfection of any contaminated equipment or your shelves, whatever in your lab. Wash up immediately after exposure, and that's you. You're washing yourself up, your hands up immediately after exposure. And if there's any splash on your clothes or in your face, you're going to have to wash your face up real quick too. Double glove to reduce contamination risk. That's a good one. And dispose of contaminated items properly. General decontamination, you're looking for a 10% bleach or anything that is EPA approved for disinfection of spills. And you'll find that also in your spill control plan and your laboratory your laboratory in hygiene plan, your chemical hygiene plan in the laboratory. So 10 to 1. So for every 10 liters of water, you do 1 milliliter or liter, whatever your unit is, of bleach. Soap and water, we mentioned that, making sure that you clean yourself up, clean up the contaminated area, and then report any incident. And if it's something that happened, and then you're reporting an accident. If it's something that could have happened wrong, but you were able to either abate the problem if it did happen, or you're able to make sure that you didn't get exposed to a hazard, then that is a near miss. And you want to report near misses as well as accidents. So everyone can get a sense of this could happen. We're lucky that it didn't happen. And here's the near miss report, so we could be aware of the hazards. So the next time the situation arises, through the knowledge of that near miss report, you can actually create a plan to avoid another hazard because you learned from your experience before. That's your key takeaways and universal precaution. That's another big takeaway on the bloodborne pathogen side. Treat every bodily fluid and blood as if it were tainted, or if it has some sort of disease. Now, this next section we're going over, we're going to talk about the flammable and combustible liquids, and we're also going to deal with the globally harmonized system. So we're going to combine these two. We'll show you how to identify combustible, flammable liquids, and then we're going to also talk about some of the precautions and cleanup and other areas to think about in your laboratory. So flammable and combustible liquids are easily ignited and ignite with explosive force. They burn readily and give off twice the heat as paper or wood fire, are commonly materials that are taken granted for and used carelessly. Those are the things that are flammable and combustible. Flammable. The flash point is below 100 Fahrenheit or 37.8 Celsius. So meaning if this liquid is below 100 degrees Fahrenheit or 37.8 Celsius, and you have some sort of ignition source, it will ignite. And some of those things are isopropyl alcohol, propane, solvents such as the acetone, the thinners, and fuels as gasoline, aerosol cans. Those things are flammable. Combustible, something that will explode above 100 degrees Fahrenheit. Oils, kerosene, gas, lubricants, oil-based paints. Those are combustible. And you need to keep your combustibles and your flammables separately, or at least if you have it in the same container, has to have a half-hour fire rating between them, so there's some time to put out the fire before one reacts with the other. Flammable and combustible material vaporizes and form flammable mixtures in the air when the exposed to air container is left open, leaks or spills occur, heated or aerosolized. Those are the ways that the flammable and combustible vapors can become a flammable mixture. So that's not even the liquid itself, that's just the vapors off of the liquid. Degree of hazard risk. You're going to determine the flash point of liquid, and we've got a really good slide with the GHS portion, and that's going to show you how the rating system for the hazards, if it's a extremely high hazard or a lower hazard, is by this flash point of the liquid. So the flash point of the liquid, the vapor concentration in the air, and if there's a presence of the ignition source, and in order to the vapors to burn or explode, it's not liquid. All right. This is part of the new GHS change. A lot of you have been used to seeing MSDS, Material Safety and Data Sheets, and we've had that for quite a while. So now the big change is SDS, which is the same thing as MSDS. However, there's very distinct changes in the formatting and the presentation of it. So it's written or printed on the material concerning a hazard chemical and is prepared in accordance to paragraph G of this section, meaning the section 1910-1200. And that's the section they're referring to, the 1200 section of 1910, which is the general industry rules. Your hazard communication is required by the chemical manufacturers and the importers. They have to identify relevant data regarding the hazards of their chemical. If the chemical is determined to be hazardous, either a physical hazard or a health hazard, there has to be some sort of information given to the end users from the chemical manufacturers and the importers. It's not necessary if the employer chooses to rely on evaluation performed by the manufacturer or the importer. So meaning their SDS sheets is material coming from the manufacturer. So now, instead of having a chemical manufacturer or importer going to your facility to tell you about about their chemical and what the hazards of dealing with their chemical is, they create these safety data sheets and they send it to you through their chemical packaging. And once you get that, that's the manufacturer and the importer informing you of what the hazard is. Hazard classification. So there's a full range of available scientific literature, and this is on the determining how hazards are classified. Hazard class indicates the nature of the hazard, meaning if it's flammable, health hazard, whatever the nature of it is, that's your hazard class. But then there's a subsequent category, hazard category, and that's your degree of severity within each of the hazard class. So if something is flammable and now it has a number to that flammability, depending on that number, that flammability could be a high probability or a high severity, or a low severity once it is flamed or ignited. Here's your physical hazards. Chemical classes in the category 1.1 to 1.6. They're flammable, oxidizers, self-reaction, pyrophoric, self-heating, organic peroxides, corrosives to metals. Something is physically going to go wrong if this hazard happens. Gas under pressure, there'll be an explosion. Water activated flammable gas. So if you have the flammable gas and you pour water on this, obviously it's going to go on fire. So you should know what you're dealing with, because some people feel that water solves everything, and water does not always solve everything. It could actually make a problem worse. And that's why you have MSDS sheets, which are now going to be SDS sheets, to show you what to use. Moving on to the health hazards. Here are some of your health hazards: acute toxicity, skin corrosion, irritants, eye disease, the gen cell mutagenicity. Of course, I always have a tough time saying that one. So while you're reading it, say it to yourself so you know what it means. But obviously, everyone's seen these new shows, movies that are dealing with mutants or something that changes your cells, and then they get superhuman strength. That's generally what the health hazards of a mutagenicity is. But you're not going to get any kind of superpowers like Daredevil or X-Men. It's something that's going to make your body some sort of degenerated disease or a cancer, and that's what the carcinogens are, the cancer-causing agent. So that's health hazards that you see. Here's the U.S. Flammability Liquid Scale. It's all in C, which is Celsius, and from left to right is your degrees of Celsius. So something with a 0 or 1 degrees Celsius that is highly flammable, that's your flash point, is in the 1 to 0 degrees Celsius, meaning it doesn't take too far, to get it to actually ignite. It doesn't have, the temperature doesn't have to be very hot. That means it's highly flammable. And then as you go up the Celsius scale, you switch from flammable to combustible. And combustible, at that point, you're going to need an ignition source, some sort of flammable, some sort of flame in order for it to combust. And that's your difference there as you're going up that scale. The OSHA RTK means the Right to Know laws. They had their own scaling system of flammable versus combustible. ANSI, the American National Science Institute, they have their own, and working your way all the way down to DOT, their flammable scale is a lot higher than some of the other ones, and they don't even have extremely flammable, or I should say highly flammable. It's just always flammable from 0 degrees Celsius up to 60.5, and then from there they go into combustible. The flammability on GHS, now the globally harmonized system, where you see Part 2, Chapter 2.6, that's referring to what's called the Big Purple Book. And the Big Purple Book is this gigantic resource from the UN, and the UN is the brainchild of the GHS, and this was getting started back in the 80s. So from the 80s till now, when there's actually a standard, there's a consensus, and it's being implemented. And if you're listening to this video and you haven't had a GHS training and it's after December 1st, 2013, which it has to be because at the time of this video, I'm doing it on December 5th, 2013. So at that time period, you should have been trained on this new GHS system if you fall under OSHA in North America. So extremely flammable. BP means boiling point. So if the boiling point is less than 35 degrees Celsius, and the flash point is below 23 degrees Celsius, then what that means is that you have a very extremely flammable material. Highly flammable is if the boiling point is below 35, but between 0 and 23. So that's where you get your highly flammable. Now, when you go down the scale to flammable and combustible, that's where you see the 60 and then 93. So on top of that, you have a number system. And your number system now is changing from what in North America you've seen before, the diamond, and we'll show that diamond that has the blue, the red, the white, the yellow. That used to be 4 was your highest, and once you get to a 4, that means something was extremely flammable. So the GHS is switching that out for us. 1 is extremely flammable. 2 is highly flammable. 3 is now flammable, and then 4 is combustible. So that's your system, and this is what it looks like by temperature and boiling point. And that's the new symbol for flammability. It's a flame with a line underneath it. The danger is 1 and 2, and then the warning is 3 and 4. So remember danger and warning, because later on those two words, danger and warning, is going to mean something completely different to you than it did before when you're in the old hazard classification system. Now, danger and warning are what's called signal words, and we'll go through that a little bit later. So that is your health hazards. Your physical hazards. On the health hazard side, using your LD50 scale, and your LD means lethal dose, 50 means lethal dose for 50 out of 100. So 100 test subjects, rats, fish, whatever it is, 100 test subjects. Out of the 100 test subjects, 50 of them died at a certain dosage. And that dosage here is saying in kilograms or milligrams. So, to go back to that, and of course I hear my dog barking. So to go back to that, you're going to see your 50 LD50. And if you guys are wondering, it's a Yorkie poo. That's my dog. So a Yorkie poo is what's ferociously barking in the back. So the LD50 milligrams is what they're using. And from 0 to 50 milligrams, if something is going to give you a toxic to your body, it's highly toxic under 50 milligrams or up to 50 milligrams. So that's your 1. Now, 50 to 500, which is a wide range, 50 to 500, that is toxic. So it's moved from highly toxic to toxic at 500. And then from 500 to 2,000, there's another scale for the ANSI all the way down to DOT. And then from 500 to 5,000, there's the EPA and the Consumer Product Safety. They're on the same scale as the EPA, where they go up to 5,000 milligrams. So on OSHA's right to know, that's pretty much what we're looking for. And let me skip down to the next one. So what that means, if you're looking at the lethal dose of 50, lethal dose 50, that 1 is anything under 5 milligrams or up to 5 milligrams. If it's going to be it'll be highly toxic at that point. And then number 2 is up to 50 milligrams from 5 to 50. Number 3, 50 to 300. And then 4 is up to 2,000, 300 to 2,000. And then 2,000 to 5,000 gives you your 5. And that's your rating system. Fatal if swallowed is 1 and 2. Toxic if swallowed is 3. Harmful if swallowed is 4. may be harmful if swallowed is 5. And that's because your lethal dose there is so high, 5,000 milligrams being so high. And now this is your danger and warning symbol. The cross and skull bone is your danger. The exclamation is your warning. And anything 1, 2, or 3 is danger. Anything 2 and 4 and 5 is a warning. Here's some sources of ignition. Anybody smoking around these chemicals and lit cigarette, either the vapors or they're throwing a lit cigarette into something like gasoline, you're going to get fire. That's your ignition source. Welding and cutting, because you've got a hot works. That's why you need hot works permit. That's in welding and cutting. Some static electricity can cause some of the flammable vapors to ignite. Sparks from machinery, combustible engines, because that's what it's doing. The combustible engine has to have some sort of spark in order for it to work, and that's things that are going to give you a flammable source. Your electrical equipment also is that. We're going to take a quick break, or at least I am, and then what we're going to do is we're going to go over the fire response, and then we're going to get to the other part of the GHS. So we're still even haven't gotten to the safety data sheets yet. So we're going to stop at the fire response. We'll do another video, and video 4 it might be the recap. It might be the conclusion, or there might be another one, but I'm fairly sure it could be the conclusion with video 4. So thank you again. So I hope you're learning a lot, and I'll see you at the next video.